Thanks everyone for coming. Just wanted to introduce ourselves. My name is Wendell Snyder, and I am the Chief Security something or other for Mozilla. I work on security strategy and help the engineering team develop security processes and work on mitigations for security issues and help make the product stronger.
I'm Mike Shaver, one of the founders of the Mozilla project, and they still let me muddle with things. I work in various areas of developer support, helping make people more successful on the web, and especially with our products. And you'll hear more about some of the ways we're doing that today.
So what we want to talk about today is let you know who we are. How many of you guys have heard of Mozilla or Firefox? Okay, awesome. So let you know who we are and talk about the security process that we use. It's a process that's being used by a product that's deployed to like 100 million people. Tell you a little bit about the way we measure success, and talk about some of the features coming up in Firefox 3 and future versions of Firefox. And then, of course, talk about the program that we're announcing today, which is a program to share tools, and introduce you to the first of these tools, the JavaScript Fuzzer.
So we'll be real quick here. I think many of you, as evidenced by the show of hands, have heard of us before. We're a lot of things to an increasingly large number of people. We're best known for making the Firefox web browser, but I think long term we'd like to be known for having made the web a better place. So that's really what we work on in our products and in advocacy and in sharing our story with people like you, even early in the morning. The hangover session, I was thinking of calling this. Most of what we're going to talk about today is about how we put things together to make Firefox as secure as we can. So who are we doing that for? We're doing that for, as of April, about 18% of the internet users worldwide. 100 million people have chosen, virtually all of them have gone out of their way to get Firefox to use as their browser. In Europe, we're especially strong, almost 25%, probably a little north of that by today. The inexorable uptick for us in Europe has been excellent, especially in Finland. Is there any Finns in the crowd? We really love you a lot, and 41%, that's a really wonderful thing for us to see. So as our user base grows and as our market share grows, our responsibility to our users obviously increases with that. And so we take our role as producers of an agent for users on the web, a tool that's got to protect them and make them productive very seriously. We also have some farther afield users. We haven't got good localizations for them yet, and the stats are notoriously unreliable, but we're glad to see that message is spreading there as well.
So I want to talk to you about how we work on making the product more secure at Mozilla, and hopefully demonstrate ways that you can use these methods in your own environment. So at Mozilla, everything we do is open source. It's open and transparent. Everything's out in the open. We couldn't hide it even if we wanted to, but we think of it as an opportunity really to help make our processes better and leverage the knowledge of the community, you guys, to improve our processes and make the application stronger. The different ways people engage with Mozilla to help us include testing in the design phase, code review. One of the things that's really special about this project is because everything is out in the open, developer documentation is available, the source code is available. People can really use this to participate in a different way than you can with traditional vendors. With a traditional security, with a regular software vendor, closed source, proprietary, whatever, you get to participate once they ship the product, identify security vulnerabilities in the product, hopefully report them back to the vendor, and then the vendor ideally ships a patch at some point. But with Mozilla, you can really participate, all along the development process. You can participate in the design meetings. Our meetings are all open to everybody. You can call in and participate with the all hands in the meetings and follow along as to what's going on in development. You can participate in implementation, in code review. People have developed tools to run against our source code, do penetration testing, and then, of course, in the traditional manner, once we ship something, identify a vulnerability, report it to us, and we'll ship a patch. One of the great things about this is that you get to spend your time in analysis and not trying to reverse engineer a proprietary format or file format or a protocol. Everything's out there, and if you email a developer because you have a question, they'll probably respond back to you because we want more help. We want to be able to help you guys join the project.
The openness there from the meetings has got us a lot of help from areas that people might find somewhat unexpected. One of the interesting things that happened when we first started to have our weekly meetings open and we finally got a 1-800 number set up so people could call in from all over the world, we discovered, in fact, that people from Microsoft have been calling in and listening and keeping up to date on what we're doing there. And it turns out they take great notes. We saw a document of them circulated around. So if the person who did that's in the room, that's awesome. If you want to keep taking those notes, we have a wiki to put them on. It'd be much appreciated.
Thank you. And one of the things that we started doing recently is trying to give real-time updates on vulnerabilities. When a vulnerability is identified, we see a lot of information out there in the community as people are trying to identify what's going on and what the overall extent is to the vulnerability. And there's a lot of discussion about it, and that's all great and healthy. We want to make sure that our users have an opportunity to understand what's going on as we know it. So we try to post the information as we have it, as it's available, and blog about it. But of course, as we have more information, things change. So it's kind of a process that we're trying to refine, giving the information, but also with the understanding that, as we find new things out, this information might change. So the security group's about 85 people. We have a consideration between being as open as possible, but not making the details of a security vulnerability available before we have a chance to patch it, because we don't want to put users at risk unnecessarily. So the compromise we've come up with is the security group, which is about 85 people, and they're representative of all different areas of the community. These are people from different vendors. These are individual contributors like you guys. This is some of the members of the Mozilla Corporation. There's about 85 people. The list is posted. We think it's a great way of getting feedback from the community without broadcasting to the entire world the details that an attacker can use to make our users vulnerable. So the security group reviews security bugs. They help us write fixes. They participate in the discussions about how to fix a particular issue. They help us design with security in mind as we're going through the process of developing new features.
One of the things that the security group also helps us with a lot is making sure that we're well connected to other members of the security community, whether that's the CVE group, making sure that we have the right IDs up for vulnerabilities that we report, that people who are distributing our software, like Linux vendors and so forth, know what's coming down the pipe in time, that they're able to adapt to that. And also to help us administer a program we've had since, in fact, we were still part of Netscape, which is our bug bounty program, where we pay cash money on the barrelhead for people reporting security bugs in our product to us. We're not buying silence. The reporter of the bug has that information. We have no leverage over them to keep them from going public, and people have after collecting, or even some cases before collecting the bounty. But that's something that we want to incent people to report stuff to us, because we believe the sooner we know, the sooner our users can be safe.
We don't think of it as paying for vulnerabilities. We think of it as like a thank you. So the other thing that's really just different about our process from a traditional proprietary vendor is that security testing is continuous throughout our development process, and you get the benefit of that work every 6 to 8 weeks in our security updates. The security updates you see from most vendors are actually vulnerabilities that are found externally and are shipped through the security update vehicle. Vulnerabilities that are identified through the QA process or by engaging security consultants to come in and do security updates are usually shipped through either service packs or in major updates. And the reason for that is that you get the benefit of a full test pass. But the problem with that is that you have to wait for a long time to get the benefit of that work. So we have built into our schedule this security updates every 6 to 8 weeks, and it's not just for vulnerabilities reported externally. It's also for our internal work that applies to security analysis. We do threat modeling on our system, on our products. We just went through threat modeling that we did as part of the process for Firefox 3. Engaged security vendors to come in and help us with that. For those of you who aren't familiar with threat modeling, it's a methodology for analyzing security software for security strengths and weaknesses by identifying entry points into the system and tracing data flows to the system. One of the benefits of threat modeling is it allows you to identify the areas of highest risk and focus your penetration testing efforts and source code analysis on those areas of highest risk. Component security review, we're actually starting that process right now. We believe that every feature has a security impact on the overall product. And so we need to look at every single feature and identify how this feature impacts the overall security architecture of the product. And sometimes these things can, not necessarily be obvious. As you introduce new features, they introduce new entry points into the system. So we need to evaluate if they're introducing new vectors into the system and whether or not we've got mitigations for those potential new issues. And and also use this process to identify whether or not our mitigations are going to be enough to protect users from potential vulnerabilities. And then develop test cases to analyze whether or not we're doing reasonable things in terms of our mitigations. We also do code review. And like I said, how do you do code review on millions and millions of lines of code, especially if you're starting with a new processor, you're looking for new things. You've identified a new code construct that results in a security vulnerability. So how do you go back over those millions and millions of lines of code and do code review on it? Well, that's very difficult. And so the place to start is with the areas of highest risk. How did you identify them? Hopefully through threat modeling. You can start with these areas and work backwards from the areas of highest risk to areas that are lower risk. So things that are highest risk include things like input validation mechanisms, anything that's handling user input directly, anything that's doing a lot of complex arithmetic or memory management, and any place where you're doing parsing. And of course, we're looking for code constructs that potentially form vulnerabilities, but also things like uninitialized variables and memory allocation and those sorts of things. We're starting from a point where we've been doing code review, but over time we identify different ways that different code constructs that result in vulnerabilities. So once upon a time, we didn't necessarily spend a lot of time thinking about integer overflows, and at some point we identified, oh wow, there's a whole set of vulnerabilities that result from these. So you should go back and look for those kinds of things. And it's difficult to make this code review scale. So one of the things that's very helpful with this is to introduce a peer review system where people review the code that you're checking in as you're writing new code, so that you're able to develop a level of confidence in the code that's new. And over time, you can say that when you started this process, the code that you created after that point is at least at this level. And over time, you get through a major portion of your code because there's a reasonable amount of code churn, at least in our code base, and you're able to have an understanding about what set of code has what level of confidence you can have in what part of the code base, unless you are keeping all your legacy code around.
We don't recommend that practice. The Mozilla code review system we've had in place for basically the life of the project now, so it'll be 10 years next March, unbelievably. But we still remember when we introduced that, and it wasn't something that those engineers had always had in place. So many of us still certainly recall the difficulty getting people to understand that even for a little change, even for something that's obvious, you want to have review. And it's not just to catch additional errors, but also to increase the number of people in your organization or project that are familiar with a piece of code. When you find a vulnerability or you find a construct that's questionable, you want to have a large number of people who can help you analyze that stuff, who can help you fix it. You want to keep your bus factor high, right? If a key developer has an unfortunate public transit accident, you want to make sure that you can still maintain the integrity of key pieces of your system. And code review helps with that at least as much as it helps with identifying vulnerabilities earlier in the process.
I think we actually covered that. So one of the other things that we do is engage security consultants. A lot of environments don't have enough resources to go over to do security analysis on a very large code base, and it's great to augment your team at certain periods of time, especially when you're in the process of doing a major security review. But it's also important to get a new perspective in there. These people are out there working on a lot of different kinds of applications, so they're able to see what other development environments are doing and bring that knowledge back into your development environment. So even if your team is great, having a different perspective from another set of security experts is very valuable.
And if your team is great, your team will want those pieces, right? The defensiveness that we know this better than anybody else. Even in a very open project, the individuals are very invested in that stuff. But the value of having other people come in and show you how to do your job better, or tell you that you did a great job, or point you at potential pitfalls mistakes you may not be making now because you've got good practices, but ones you need to make sure that you defend against in process as well as in code over time. And certainly, as Windows said, having access to people who have experience with a really broad range of applications is has been really valuable to us, and I think would be really valuable for anybody that is looking to take their security process to the next level.
It's really easy to get invested in your projects. I think we all really get invested, personally invested in our projects, and some organizations fall into the trap of like, not invented here. So it's nice to have someone come in who who is not personally invested, who's got a bit of distance from the project to just look at things and say like, well, you could do this better. This might be a reasonable way another way of going about things that might be better aligned with your goals. We've worked with Modisano, Leviathan, IOActive, ISEC. We are always looking to work with different organizations. So if that's something that your organization does, we want to hear about it. And of course, we use automated penetration testing, and we're going to be talking about some of the fuzzing tools that we use a little bit later. But we find fuzzing to be a very practical approach to looking for vulnerabilities. We're able to target to specific components, to file file parsers, to different image formats. And we use this to identify whether or not an existing library that we're potentially considering incorporating into the system is whether it's squishy or whether it's pretty solid.
One of the important things for us too, especially for a product like a web browser or web server where your entire life is about potentially hostile interactions, the whole of the web for us is code and content we can't trust, is to remember that when people are building attacks, they're not too concerned about whether the page validates. There are a lot of test suites out there that will verify the correctness of behavior according to standards for different kinds of formats or protocols. And those are useful, certainly, in validating the quality of your application, but they have very different coverage behavior from fuzzers, from things that are intentionally hostile. Whether you're capturing existing attacks and figuring out, using those as a base for your testing, or building tools to spread through that potential problem space much more quickly, it is important to keep in mind that perhaps obviously attackers are not going to play by the rules, not only sort of rules of convention, but also rules of the formats, rules of ordering, and those sorts of things. So the depth and breadth of your testing there can have a really significant impact in how effective the technique is for you.
Yeah, they're not necessarily limiting themselves to the RFC, so you shouldn't either. And of course, we do manual penetration testing, and we want to develop test cases to make sure that we're addressing all the areas that we're especially concerned about. And as Mike brought up, we are not just testing. This is not just functional testing. This is negative testing as well. This is not just, is the application doing what we expect it to do? It's what happens, what does the application do when it receives data that it's not expecting? And then any issues that we identify, we want to validate them through source code analysis, and that makes some of the source code analysis also a little bit easier to manage, because we're talking about millions and millions of lines of code. And this is also a way to address areas that are hard to do through automated testing. So I talked a little bit about security updates at the beginning, but I think this is actually an important distinction to make, that we are continuously shipping the work that we're doing, all the work that we're doing in security updates on a 6 to 8 week schedule. This is different because we want to make sure that our users don't have to wait for a major release to get the benefit of all the security work we're doing, and that is different from what the vendors are doing, what the other vendors are doing. The problem is you can't see from the outside how many bugs are fixed internally, especially if they're fixed in a large package like a service pack or an update. So it's hard for any environment to ever analyze against another. If you're looking at the number of bugs, to ever analyze against one product to the other to say, oh, well, there's this number of bugs over here and this number of bugs over there, because you can't actually count the number of bugs in any other environment if everything's not completely transparent.
Giving the updates to users frequently also has had effects, we believe, in encouraging users to update. If you drop a new product on them every 6 years, they have to adjust to all of the changes that have been made there in one go. Sometimes, in order to preserve the integrity of the application, we need to make changes that may render some sites slightly incompatible, that may, in rare cases, break an extension. And doing that frequently keeps users engaged on a piece-by-piece basis. We can deal, especially with a relatively small organization in a large project, we're able to look at those cases on a much more regular pattern rather than having a huge burst of things to deal with, potentially difficult interactions between fixed sets once every 3 years, once every 6 years, or even on our major release schedule right now, once every year. So that's been very helpful for us in making sure that we have the ability to make changes that are painful for the application, and we can sort of spoon them out a bit at a time. It's been a lot easier for people to absorb.
So one of the things that you can use to apply this in your own environment is to evaluate whether or not waiting makes sense in your environment. So a lot of vendors do this. A lot of vendors put the security work they're doing into service packs or into major updates because it gets the benefit of a full test pass. And if you are testing application compatibility with 500 applications, that's a pretty serious test pass that you're doing there. But it's reasonable to evaluate whether or not the value of this test pass is required for all these security fixes, and are there some security fixes that can go out in security updates so your users can get them quicker. We've seen some vendors, unfortunately, put security fixes in major updates, and major updates that actually require paying to get this. And that's, I think, if it's a fix and not a feature, right, then it's probably something that should be shipped to everybody, not just the people who are paying for the next major update. And I think that it's important to consider, and I'm sure it's known for everybody here, but it doesn't seem to be clear to all the vendors that just because you found it internally a year ago doesn't mean that it's not known externally, that someone else didn't use the same method to find it that you did. So waiting a long time also exposes users to more risk. So if you can get those fixes to them faster, then you've reduced the window of opportunity for an attacker. And it's unfortunate to make your users wait just because there's a ship vehicle coming around in 6 or 9 months.
And that's actually something, we have a 6 to 8 week update schedule, but as some of you may have seen, that doesn't keep us from doing what we think of as emergency updates, where there's a vulnerability that's out of cycle, that's public, that's putting users actively at risk. Recently, 10 days after we shipped 2.0.0.5, we shipped 2.0.0.6 because we found a vulnerability that we believe we needed to address right away. We didn't even want to wait for that 6 to 8 week ship vehicle. Some fixes we'll look at and say they're because of severity or because of they're not being they're not being exploited. These sorts of things we'll wait for that 6 to 8 week vehicle to amortize some of that testing. But where you need to do something aggressive to keep your users safe. That's something that you consider independently of what your product schedule is, because it's about being reactive in that case, and you need to decouple those things, I think, to keep users maximally safe.
So we're going to talk a little bit about the metrics and how we evaluate whether or not we're being successful in security at Mozilla. So in your environment, you probably have managers asking all kinds of questions that that are difficult to answer, except for the first one: should I be worried? The answer to that one's always yes, right? Are we getting better? That one's hard to evaluate, right? So these are the things these are the ways we're trying to answer some of these questions.
And this is an area also where we are hoping to get benefit from sharing that. One of the reasons we want to talk about what we're doing is not just so that you can avoid having to learn the hard way some of the things we've learned, but also so that you can tell us where we can be doing stuff that's better, where you can share your experiences with different kinds of metrics, with different kinds of measurement, different ways of framing these questions. So for us, this is a process that's is very much ongoing and one where we're very receptive to feedback and input.
There are a lot of people working on this, like Dan Gear and Andrew Jaquith over at securitymetrics.org. And these are actually really difficult questions, like how do you measure security? These are the things that we're using, and we want to make sure that we're doing reasonable things, first of all, and get feedback from you guys. And if it's something that's useful to you guys, maybe you can apply it in your own environment. But it's a difficult thing, and one of the reasons is that it's hard I think one of the easiest things to look at is the number of bugs. And for a lot of reasons, just counting bugs doesn't work. Like I mentioned earlier, that you don't actually have a good measure against any other environment. But looking at just bugs doesn't tell you much about the quality of the bug. It doesn't tell you about how fast you're finding them, how bug dense a particular area of code is. And so on, and especially across different projects. I mean, you can use it to evaluate something in your own project, but to evaluate across projects is very difficult because you can't actually count the number of bugs at any vendor unless you can see them from the inside and the outside.
And this is an area where I think the historical focus on sort of raw bug count, right, stack them up beside each other, see who's shorter, they get a ribbon, has created some unfortunate incentives for people in the behaviors they show and how they report security vulnerabilities. There's a very strong incentive, especially in a competitive marketplace, to be reporting fewer things that make you look bad. We are in an environment where the sooner we look bad, the sooner we are good, and that's been very successful for us. But I think even as consumers of technology, in addition to being developers of it, that focus on only the things that it incents around only saying what you have to about your vulnerabilities, minimizing them where you can, bundling them together to make them, so you're not written up in the press as having 500 vulnerabilities in this one release. works against people understanding more about the security characteristics of the products they use, and it works against sharing these lessons across the width of the industry. So we're certainly interested in encouraging people to be more explicit about the kinds of things they know about their application security, and we're interested in people telling us where we should be doing a better job. We want to raise the expectations across the industry for how people think about and reason about and compare security of systems.
It should be the kind of environment where a vendor could come out and say, we fixed these 200 bugs. And the story should not be, oh no, product X has 200 vulnerabilities. The story should be, vendor fixed 200 vulnerabilities, because that's really, at that point in time, they're fixed, and we should congratulate them for that. But like, that incentive doesn't really exist out there currently. So they are unfortunately in a situation. And if we look at number of vulnerabilities as the primary metric for evaluating the security of a product, we do encourage them to group bugs and to potentially not identify every single bug. So the things that we're using internally are severity, and well, internally and externally is kind of the same thing for us, but is severity, the find and fix rate, how long it takes us to get a fix out there, and how long it takes for our users to get that fix deployed. So we use severity to evaluate what to fix first. We still identify any bug with any level of security risk as a security bug. And just because something has a low severity doesn't necessarily mean that we're not going to address it, but we need to figure out what to do first and how to prioritize. So we assign severity rates. It also helps our users understand how spun up they should get about a particular issue. How serious is this? What is the impact going to be to me? And this is language that can be accessed without understanding all the technical details of a particular issue. There's no standard industry standard, although it seems like every vendor's got their own standard. But for the most part, they're similar. But it would be nice to see if there were an industry standard that we could all agree to. But at least we're consistent with ourselves over time. One of the things that is different about us is that if anything could possibly be considered critical, then we decide that it is critical, because we'd rather not be wrong about this. We'd rather over-report the severity of an issue than under-report it and not have users take it as seriously as they should. So if there's any potential for an issue to be critical, then we consider it critical. Critical means for us that an attacker can run code from remote and there's no user interaction required beyond normal browsing. We consider normal browsing clicking, so if the clicker is required, then we still consider it critical. High is the severity we assign to any issue that allows you to gather any kind of sensitive data or else inject data into those sites, and again, with no special user interaction required. Moderates include issues that are unlikely because of very uncommon non-default configurations, or else require contortions for the user to jump through before the attacker can be successful. And then low includes things like denial of service, because we're a client-side application here. So denial of service, in our cases, like either the browser becomes unusable or hangs, for example, or else a minor data leak that's not personal information or potentially spoofing. So as we're looking through our bugs, one of the things that we're really considering is the find rate. Are we getting better at finding bugs? Are our tools becoming less effective because we've found the bugs that this particular tool knows how to find? This is why it's important for us to look at the find rate. And it's also important for us to know, how many have we found and what is the overall severity there. So that helps us identify what methods are productive and what methods are, let's say, less productive. So it helps us figure out where to put our time. So for example, we did some work in source code analysis. Actually, one of the source code analysis vendors came to us and asked, and did some work on our code base, ran their tools over it, and then reported that they had identified 300 vulnerabilities in the Firefox code base. And what they had actually done is flagged 300 constructs that could potentially result in vulnerabilities. But when we looked through these, none of them actually resulted in actual vulnerabilities. So this particular tool was 0 for 300. So we can look at that and say it's not a very effective tool for us, and that it's as a method, our investment in time is probably better spent elsewhere.
And one of the things that people need to sort of track is what's the cost to your organization of waking up one morning and you read the headline or you get an email from your VP that says this tool found 300 vulnerabilities. What are you going to do about it? If there are 300 vulnerabilities in the product, you've got to do something about it, and you got to do it very quickly. And the energy cost for dealing with those false positives is higher, I think, for security bugs than for pretty much any other kind of defect. going to talk a little bit later about some areas where we have had good success with source code analysis. But again, as is a pattern through a lot of this talk, it's more about making sure that the things you do suit your environment and your product and are aware of the things that can take advantage of your experience than necessarily taking the tool that worked great for somebody else and applying it blindly. So certainly you need to be, if not cynical, you need to be careful in how you interpret the results of tools and reports from other sources that may not know your product as well as you do.
So one of the things that we look at is okay. So are there themes? Anything that we can pick out here? Is there a trend? These spikes are the points where Jesse introduces new tools here. So we're like, okay, new tool introduced, it becomes less effective over time. New tool introduced, less effective over time. But we're able to identify, okay, these tools are effective. Jesse's good at writing tools. I think this is what we're able to determine from looking at these things. But we're also able to evaluate, okay, this tool is no longer effective. Maybe this is a point in time where we can make it available to the public and see if other people can maybe tweak it and make it more effective for us. Or maybe they can use it in different projects and make it more effective. And we were able to use that to identify that we were able to make the tools that we're talking about today available.
We'll take actually questions at the end if you want to.
He's asking what are the numbers here. So like the point of the slide is actually to demonstrate that we're seeing, when we see spikes, like we can attach it to something else. But we can make the numbers available. I don't have them here in front of me, obviously, because this is, we're looking at the same thing. So things that we're looking for are, actually, if you want to.
Yeah, this is again an area where the philosophy of why we use tools, I think, is valuable to share. Window will ask what methods are most productive, and Jesse will have found a new way to blow up some piece of our browser. What happens when I poke it in this way? And then, of course, all the various engineers are like, why do we even let people poke it in that way? And it's because it's the web, of course, so you have to let them poke it in various ways. But for us, one of the real values of tools is that they let people who are experts empower people who aren't experts to find bugs in these ways. They let you capture that expertise in some piece of software that can be used even by a mortal software developer. And use those tools and techniques, whether it's to extend the domain language that the fuzzer might search, or to run it over different kinds of patches that they're working on to make sure that they haven't regressed in an important area. That aspect of tools is I think, at least as important to us as the automation aspect of it, though, as we'll see, the automation aspect is pretty powerful as well.
The other thing we're looking at is fix rate, and this is actually important to identify, because if your fix rate is lower than your find rate, then you will end up with a backlog, and that's a scary place to be. That means you know about a whole bunch of bugs that you can't get fixed quick enough, and you're constantly adding to the set of bugs that you know about. And so over time, the tail is growing, and you can't keep up with it. So that's a scary place to be. But if you don't know your fix rate, then it's hard to identify if you're in that situation, if you're slowly digging yourself out of that hole, or if the hole is getting deeper. So it's important to track things like your fix rate. It also helps us identify, are we looking at some bugs that are incredibly difficult to fix, and are they backing up the rest of the queue? How can we schedule our resources a little bit more effectively?
And also, where do we need an architectural change that may not be suitable for an update, where we need to mitigate in one release, but we need to take a different approach in another major update to change architecturally how we deal with this class of attack or this class of operation. And looking at the information about fix rate, whether you're heat mapping your code or you're looking for patterns in whose code most frequently has this bug, those are things that help you identify where to spend your resources and where you may need to change tactics in order to get to the fix rate you want.
For some bugs, you actually have to play whack-a-mole, and as they come up, whack them back down. But if you can implement a architectural level change that mitigates a whole category of bugs, and then you can knock out maybe 10 or 20 at once, and that's important to realize, and recognizing when those things are being successful is one of the reasons that you want to track the fix rate. And it also helps us identify regressions as well, because it's hard to identify how expensive a particular cost fixing a bug is going to be in terms of how long it's going to take until you actually get into the guts of it. But if you have a rate of regression over time, you can use that as part of the cost of the fix, because that's at least something you can average from previous fixes. So our fix rate ends up looking like this, and it's hard to tell for us what's going on. So we're still looking for trends in our own fix rate and trying to tie it to something else. But what we're seeing is that we are the places where it spikes are places where a major fix lands that mitigates a broad category of vulnerability. So we can make sense out of it at that point. But in terms of like, are we getting better at fixing things? Are we fixing more and more bugs at the same time? Well, we are able to fix more and more bugs when we add more people to the set of people who are fixing bugs. And we are able to fix more bugs at a time when we implement architecture changes. But we absolutely need to add more people to our to the set of people who are fixing bugs, because our find rate is getting pretty high up there too. And we're of course constantly encouraging you guys to hack away at the product and identify vulnerabilities and report those as well. So as you guys take up that challenge, then our fix rate needs to get better too. So if there's other people here who want to help out on the fix side, not just the find side, we'd love to have you participate.
This is another case, too, where picking your metrics and picking how you align your organization around them can have a really profound effect in the downstream security of your system. If the edict is our fix rate needs to exceed our find rate, you're incenting the system to underreport bugs, right? You're just saying, well, we should have somebody going and fixing some of these things instead of, fixing one bug instead of writing something that might help us discover 50 of them. And that may not be the right behavior to get you to where you're looking to be in terms of security of your product. If we wanted to just optimize, if our goal was the next year at Black Hat, we're going to be able to show these two lines and one's bigger than the other and there'll be rousing applause, we would just put Jesse in a box for a year. And that would be fine, and we wouldn't find any of these bugs. Other people, of course, are not motivated to keep our fix rate above our find rate. They're motivated to find as much as they can. So we need to stay ahead of that, and we need to figure out how to be smart about how we approach fixes as well. But that one top line number can be misleading, and it can point your organization in the wrong direction if you're not careful.
You can also use these numbers to identify a need for headcount for the set of people who are either fixing or testing. So the last set of metrics that we're looking at is really two parts. It's the overall window of risk, the opportunity an attacker has to potentially exploit a vulnerability in the software. And that's made up of two parts. And the first of these is how long does it take for the vendor to ship a fix once it's identified? And the second part is how long does it take for the user to get the patch installed? And that's important, and I think part of the story that's been largely ignored until recently, because attackers don't care whether or not the fix is available or whether the user doesn't have it installed. If the user is vulnerable, then that's all they really care about. So I think both parts of those are really pretty important. So on time to fix, we're getting better over time, and this is actually largely due to your support, and we want to thank you for that. We have about 20,000 people who download nightly builds every night, and that's incredible, because that means that we're able to test our fixes against 20,000 different host configurations with 20,000 different driver sets and 20,000 different applications with 20,000 different users doing different things on 20,000 sets of websites running 20,000 different configurations of plugins and add-ons, and that's huge, because we couldn't get that kind of breadth no matter how many resources we had internally to throw against it, right? That's an amazing test bed, and so your support in running nightly builds is what enables us to ship fixes so quickly. That is you can get a little bit better at identifying the problem once somebody reports it and poking around nearby and seeing if there's similar issues. You can get somewhat better at that. You can get a little better at identifying how to fix it. You can get a little bit better at building the fix a little bit quicker. But the thing that we are making the most progress on is reducing the time to test, and that's what we're able to do through the support of the community, and that's tremendous. And that's people, that's users, that's developers, that's our neighbors, that can be really anyone. Run the patch, run the build. If you have any problems, let us know about it. Otherwise, we develop confidence in the integrity of the patch, and we're able to get it out quicker. The other half of this is time to deploy. How long does it take for the user to get the update installed once it's available? And this is one that we've been tracking, but have only recently started to use it to evaluate whether or not we're doing a good job internally and talking about it externally. For us, this has been tremendous since the implementation of auto update, because it means that users are able to get fixes automatically. They don't have to go out there and dig for the update themselves once they hear about it. It's actually sent to them directly, and that's tremendous. And it also helps us identify what percentage of our user base is updated through the requests that come in to identify for auto update. So this is what the upgrade cycle looked like when this is last year, when we shipped 1506. So this is the cycle from 1505 to 1506. The red line is 1506, and the blue line is 1505. And it's not a pretty chart because I'm not that good with Excel. But on day 3, you can see that there are more people. So day 1 is when the patch shipped. Day 3 is the day that more people have the patch than don't have the patch. And by day 8, you can see that about 90% of our user base is updated. And I thought at this time, like 8 days ago, that 90% of the user base being updated in 8 days is pretty tremendous. Because we're talking about 100 million users or something like that. To get everybody updated in about 8 days is pretty amazing. So this is the upgrade cycle for 2004, and this was just in June, at the very beginning of June, when we shipped 2004. I'd actually like to see these numbers for 05 and 06, because those shipped out back to back each other. But what we're seeing here, and even though these charts look exactly the same, as Mike was pointing out to me, the difference is that this chart's only 6 days. It takes 6 days for 90% of our user base to get updated, and that's tremendous for us. And that's due to some changes in our infrastructure and some support from our mirrors, and that's pretty tremendous. That means we're able to get that many more people serviced that much quicker. That's a 25% improvement and a reduction in the amount of time that users are vulnerable.
And that's certainly, as an engineer, that's a very gratifying experience, right? You worked hard to fix this thing. You want it. You did it because you think it's important to protect users. You know it's important to protect users deep in the core of you, and you want to see those users protected as quickly as you can. So being able to see that stuff in the hands of users as soon as possible has a big effect. The question is, how do we know this represents all of our users? And we don't. It's a stochastic analysis of it. One of the perils, one of the costs of being very attuned to our users' privacy is that we don't track individual users in that way. People can get their sources. There are people on intranets who talk to different update services that have been set up in different places. But with the scale of 100 million users and looking at the scale of the pings that come in, we're quite confident that these are representative numbers. We have a economist statistician actually on staff now who will be climbing through these things and making sure we know what our confidence intervals are and so forth. But where we've been able to look at other cues around vulnerability, around user agent stats on different sites, we've seen that they very closely mirror the numbers that we're seeing here. So we think it's a pretty reliable indicator.
Okay, so we need to keep moving here. So
yeah.
we're going to start talking about
you need to listen very quickly now.
What's coming up in new versions here?
Absolutely. So obviously we do more than just fix these bugs in security updates. And one of the things we try to do with each of our product releases is think hard about what are users doing with the product that is related to their security. And some of these are obvious, right? They clicked the URL, they didn't want to get owned. They entered a password somewhere, they wanted to know if it was the right kind of site. But there are other important user tasks. One of the ones we've just spoken about is getting people to update their friggin' browser. We've got a great record on that. We're happy about it, but 6 days is short, but it's 6 days longer than we'd like it to be. So look at those user tasks and think about how we can make them better. And sometimes we find, in some cases in retrospect, some nice things that we can do to the product that improve some of these user tasks. So things that would be obvious around applying an update would be more bandwidth to user, more bandwidth to the mirrors, more frequent checks done by the browser. We did work many versions ago to ship very small binary deltas instead of whole files or whole packages. So you download 300K instead of 7 megabytes. We also thought about, why do users decline updates? We know that, we're seeing we observed it in user behavior, and we saw stats that made us believe it was widespread, that users were being notified of the update but not choosing to apply it right away. And that's very frustrating. We've got something that will help you. Please let us help you. And the big two reasons that people were afraid to do it, one is that it's too intrusive, right? Your browser's going to shut down and restart. You're going to lose the work you're working on. So I'll do this after I finish this blog post or after I finish reading Penny Arcade. And then you forget, you've declined it, and you leave your browser running for a long time. So it's 2 or 3 more days until you might get notified again or restart your browser for some reason. And in many cases, they're worried about things breaking. The software industry has a horrible record of patches breaking inadvertent stuff. This is an area, again, where our huge tester base and shipping these updates out in small pieces where it's easier to analyze the interactions has been really helpful. So for us, Succession Restore, which is a very popular feature of Firefox 2, when you restart your browser, it comes back where it was for us a security feature. It's something that made it less painful for users to apply updates, and we believe is one of the reasons that we saw that 25% decrease in time to deploy. And API stability is a security feature. Don't break my crap because you made me more secure. Don't make me choose between taking something that will protect me and getting my job done, where you can avoid that. And that's, again, an area where doing these in small pieces means that you're not going to have the whole of the web break when you take a large update. So there's a whole bunch of stuff we're doing in Firefox 3 around improving security of users, both security in the integrity of the code sense, but also security in their behaviors. My colleague Jonathan Nightingale has an hour-long presentation about some of these pieces, which is excellent, so you should mug him for those slides. But we'll give you an overview of some of this stuff here. We did this in Firefox 2, and we're working to make it better all the time. We suspect this is a web forgery. We tell the user that. One of the important things here is that it's in the user's face. They went to this site because they're interested in the content. We know through painful and depressing user studies that users don't look at the Chrome. They're there to browse the web page. They're going to look at the web page. It's got the eBay logo on it. They're going to type their eBay password and get on to what they were trying to do. So it's very important we build these notifications that they're in the way that they can't be ignored, that they can't be missed in this distracted sense. Now you can still click through it, which is the case of many security warnings about bad certificates or possible mismatches, and we're reducing that set of things.
But it also looks different than other security, other dialogues. It doesn't look like any of the other dialogues. It's something completely different. So it takes the user out of the context in which they've been trained to click OK through the certificate warnings or through other dialogues that come up.
And this is, again, an area where making sure that that you present these things where you're sure means that users don't get numb to them as quickly. So in Firefox 3, we're adding support for keeping a different kind of list of bad sites or heuristics that will be suspected attack site that's trying to install a Trojan on you in various kinds of ways that it's been known to be shipping things to you that you really don't want on your system. And one of the things that you'll notice about this is we were pretty aggressive here. There's no click through on this. This is, you're not going to go here. Which is not going to be without controversy, certainly, and we believe strongly in user choice. But in order to protect our users better, we're going to have to be brave, as Jonathan says, about doing things that are going to see complaints, but we believe are also going to have very strong effects in protecting users better on the web. One important note here, maybe hard to read on the slide. This is a mock-up. Mock-ups change, so don't over-report that. You shouldn't start building your Firefox 3 reviewer's guide on the screenshots and mock-ups I'm going to show you here.
Yeah, until the product is shipped, there's nothing that's set in stone.
Yeah. Now, if you're interested in these kinds of things, there's certainly one of the benefits of the open bug system is you can follow along with our work there and you can tell us where we're screwing it up. So please do. So I'm going to go very quickly now, so we've got time to show off Jesse's awesome stuff. One of the things we also try to do is take advantage of our large user base, not in the take advantage sense that's most common in Vegas, but to derive maximal advantage from the fact we've got 100 million users. They all care enough about the web to download their own browser, and they may notice that this is a phishing site and help report that back to us, that we can give that to the people who maintain those databases and gradually improve the quality of that. We do the same thing with crash reporting. Many crashes are security related or can have a security impact. So as we're doing things with testing, we get crash reports back in. We get an aggregate of these things to help us look where do people need to update their plugins better? Where do we need to mitigate against a problem in a plugin? Where are we seeing uptake of content that's causing these things to be more common? So please submit your crashes. They help us a lot. Very quickly about EV certificates for reasons of time and personal preference. SSL certificates are intended to verify the identity of the site. Turns out that if you don't verify very well, you can ship certificates more cheaply, and there was really no reason not to, so that kind of sucked for a while. EV certs are more thoroughly validated now. Someone goes on site and so forth, so you have a higher confidence in site identity. So one of the things we're introducing in Firefox 3 is the notion of LARI, the international symbol for passport control, which of course is a wonderful identity document. LARI's there. It'll show you the site identity. In this case, we've got SSL and we got a high validation certificate, I believe. So it shows LARI's confident that this is really who it is. One of the important things, though, is that LARI will always be there. One of the problems with the padlock is that it only tells you you're safe. And when you're safe, you don't need to know you're safe. You need to know when you're not safe. So in this case, LARI's always going to be available to tell you about that site. So even in the normal case, you won't have to detect the absence of something. You'll know that we don't, and we believe the Mozilla.org site to be a pretty reasonable place to visit. Don't get me wrong, but we can't prove to you that that's where you really are. So you need to be careful. And again, please don't over-report this, or Jonathan won't let me use his slides anymore. There's a lot of information about web security. It's hard to express to users, so we've done some work to improve that over time. In Firefox 3, we'll see some uptake of this as well. One of the important pieces here that's quite interesting to me is, have I been to this site before? If you're trying to figure out whether you should be trusting this site and so forth, that's a good indicator that it's probably the site you think it is. Is it storing cookies? Have I saved any passwords for this site and so forth? There are certainly other things we want to show in this environment, and we're interested in hearing from people's experiences or even just strongly held beliefs about stuff that would be valuable here and understandable, again, to our 100 million users and growing. The users themselves are not growing, but the base is. Under the hood, we've done a ton of work on core technology. We'll skim through some of this stuff here. One of the most important pieces, we rewrote a huge chunk of how we lay out our code, how we lay out web pages, rather. And one of the big reasons was to improve the resilience in error handling cases, in low memory conditions, in the kinds of stuff no one should ever do to a page, but probably will if they're trying to break your browser. Thank you, Jesse. To be much more resilient. This is an example of an architectural change that we're doing in parallel with spot fixes for bugs that we find, to reduce the aggregate and the broad swath of these bugs and the whole class of bugs in that update. And there are a bunch of these things that this could have been a whole talk on its own, but important is we're looking at these as we're looking to review these kinds of code. We're not just looking, are there new vulnerabilities in the code? We're also looking, is there an opportunity as we change these things to improve the aggregate security of the system? In a deeper future, not 2007, probably not 2008, but work we're actively undertaking right now, project we're calling Mozilla 2. One of the big advances is a JITting JavaScript virtual machine that we're working on with Adobe. They donated, was part of the Flash player, is now both part of Flash and a future version, distant future version of Firefox. One of the real great things about this is going to let us move more code from traditionally fragile C++ into a managed environment where we don't have to worry about memory management, where we don't have to worry about certain kinds of pointer manipulation or mismanipulation, string management, and so forth, reducing also the sheer amount of code people need to write. The fewer keystrokes they have to enter, the less chance there is that one of those keystrokes is subtly incorrect. And we've found in a lot of cases that where we're able to rewrite code from C++ to JavaScript in the product, where we see a reduction in bug rate in those things. We've done this with the password manager in Firefox 2. And this will give us a way to do this at a larger scale in the application. This is also an area where we've built some custom static analysis tools on an open source project called Oink to help us when we've identified a construct that we believe to be problematic now, to help us do that historical analysis over the aggregate of the code in there to let us know which pieces need special attention, how widespread the problem is, do we need to write a tool to fix it, or do we need to defend it at a lower layer, or are there only 5 cases and we can just go in and fix them. And these tools are also things we'll be adding to the pre-check-in validation to make sure that we don't regress in these cases. Even today, there are certain cases, misuse of Boolean variables, that will get developers emailed now if they check in something that introduces one of these patterns. So, what you really came here for, talk about some of our tools and the project we're announcing now, and I'll let Window tell you a little bit about some of the stuff we're doing here.
Okay. So, the reason we're making these tools available is because we think they were valuable in our environment. They might be valuable in your environment. But we want to make sure that as we release these, that we're doing it in a way that is as safe as can be for all the other applications that could potentially be impacted by this. So we engaged the other big browser vendors. To make sure that they had a chance to look at these tools, evaluate them, and let us know if they had any concerns. And I did get positive confirmation from all these vendors that they did not have a problem with us releasing the tool that we're releasing today. So I want to make it's a real pain in the butt when someone releases information about a vulnerability without giving us enough time to fix it. So we wanted to make sure that we weren't doing that to anyone else.
And we're very grateful for their cooperation as well. Certainly, there was a past world of browser competition where people would have just said, no, we're not going to let you do anything you want to do because it'll be bad for us. But certainly the people that we've contacted in these organizations share the same goal we do of making the web safer. And so we're grateful that they're working with us on helping us release these tools now and in the future.
Absolutely. So the ones that we're going to be talking about today, and actually since we've got 2 protocol fuzzers that are actually coming out in a couple of months, and since for time constraints, I'm actually going to go ahead and skip to the JavaScript fuzzer, which is what's available right now, and turn it over to Jesse so he's got an opportunity to talk about this.
So I started writing this fuzzer about 11 months ago. It creates random JavaScript function bodies and asks the JavaScript engine in Firefox to compile them, run them, and decompile them. It does this by the function make statement knows that one way to make a statement is to have var and then variable name and then equal sign expression and then semicolon. And then it knows to make the expression part of that. Make-Spur knows how to make a bunch of different types of expressions. But then also it'll violate all these rules it knows. So sometimes where the var statement calls for a variable name, it'll stick in a pound symbol or a try keyword or whole expression. And that helps it hit syntax error handling code in the JavaScript engine. It's found a lot of bugs, including 24 exploitable bugs, and I think it's able to do this because it knows a lot about the JavaScript language, but it breaks the rules it knows. It's not scared to make deeply nested statements, put things in loops, and it can also accumulate state as it runs lots of different functions. And it's also testing for certain aspects of correctness, so it's not just finding crashes. And here are 3 examples of exploitable bugs it found. In the first example, it made an example an object whose toString function triggers garbage collection, and then when the post decrement operator ran, it was a dangling something got garbage collected that still had references to it, and that created a dangling pointer situation, and that caused a bad crash. The second example is just an example of nested statements that were necessary to cause a crash. And the third example is an example where some state needed to accumulate. It had a setter and a watch point for the same variable name, and then triggered garbage collection, and that made a simple statement crash. You can get this tool by going to Bugzilla and typing in JSFunFuzz as the bug alias.
We'll be putting together a permanent home for this tool and other ones we'll be releasing, but we wanted to make sure we didn't want to say, oh, we'll release it once we've got a great website for it, because the tool is really the meat of the operation here.
So that's available now, and we'll also be announcing further tools as they're available on the security blog, which is available at that URL. So for information about Mozilla Security, these are the URLs that you want. The security blog is the best place to look for ongoing announcements about security issues, security tools, updates, any information that we're making available, and a couple of other projects that are available at the URL at the bottom. There are a lot of different ways that you guys can get involved. This is the last thing we're going to say about this. You can be an evangelist, join Spread Firefox. You can give us feedback. You can develop add-ons and implementations. You can be a contributor. You can run nightly builds. And specifically, security folks can do a lot in by participating in the design conversations, by developing tools, by identifying vulnerabilities, doing penetration testing, reporting them back to us. And we really appreciate all the work that you guys do that helps make Mozilla secure.
So thank you. And
thank you.
You're too kind. You're too kind.